Hello, welcome back to our series on factoring. Today we're going to take a look at some complex factoring problems where you may need to use more than one method in order to completely factor your equation. All right, so let's get right to it. And if you have not taken a look at some of the earlier videos on factoring, you may want to do that first. Just pause this, go look in the comments, click on those links, and then come on back and continue this one. Okay, let's go. All right, so here we go. We have 2x to the fifth minus 32x. This is not a quadratic. We cannot use the x method. So the next thing we would want to check is there something common to both terms that we could factor out? So already I notice there's a 2 and a 32, so those will both have a 2 in them. And there's an x to the fifth and an x, those will both have an x in them. So my first step here is going to be to factor a 2x out of each term. And so 2x to the fifth divided by 2x leaves me with an x to the fourth. And minus 32x divided by 2x leaves me with a minus 16. All right, am I done? No. I have a two-term equation here with a minus between them. So I'm going to check for difference of squares. X to the fourth, yep, that is a squared term. 16, yep, that is a squared term. So I know that this can be factored using difference of squares. So I know that one of these will have a plus, one will have a minus. I know the first term of each will be the square root of this, which is x squared. And I know the second term of each will be the square root of this, which is 4. And then I know my 2x is still multiplied to the outside. Am I done? This term is fully factored. This term, well, there's an x squared and a 4. Those are both squares. That is not a difference. That is addition. So this term is fully factored. But over here, this is a difference. So this can continue to factor by difference of squares. So again, 1 plus, 1 minus. First term of each of these is an x. Second term of each of these is a 2. And then again, I bring down the rest of what we were working on. Now, fully factored, fully factored, fully factored, fully factored. This is the completely factored version of where we started. Let's do it again. Okay, so here we have a 3-term equation, but our first term is not an x squared. So this is not a quadratic. I can't go straight to the x method. So again, I'm going to check and see, is there anything common to each term that I can factor out? Well, I see right away that 3 and 12 is divisible by 3 and 36 is divisible by 3. So I know I can at least pull a 3 out of every term. And then I see an x cubed, x squared, x. So I know I can pull an x out of each term. And so now I'm going to see what's left. 3x cubed divided by 3x leaves me with x squared. 12x squared divided by 3x leaves me with 4x. And negative 36x divided by 3x leaves me with minus 12. Now, this is a quadratic. So I can jump over to my x method. Up top goes 1 times negative 12, or negative 12. Down below goes the coefficient of my middle term, 4. I'm going to make my factor list, 1 and 12, 2 and 6. Hey, that's looking promising. So if I need to multiply to negative 12, but add to positive 4, my 6 wants to be positive, my 2 wants to be negative, and 6 times negative 2 is negative 12, so check. The coefficient of my x squared is a 1, so these are what go in the parentheses. So I've got my 3x on the outside, and then I've got an x plus 6, and an x minus 2. And this is the fully factored version of this. Let's do it again. So it really feels like a quadratic, only we're starting with an x to the 4th term. Well, your instincts were right. This is a quadratic. We are going down by 2, right? Our previous one, we had an x to the 3rd and x squared. We were only going down by 1 degree between terms. Here, we're skipping again. X to the 4th, and then we go down by 2, x squared, and then our final term is just a constant. This is a quadratic in disguise. And instead of our initial term, instead of this being a parentheses that's going to end up being x times x as the first terms in the parentheses, it's going to be x squared times x squared. But otherwise, we can go ahead and operate still using the x method. So we make our x, we say to ourselves, okay, this top has to multiply to 1 times negative 18 or negative 18. The bottom, again, wants to be the coefficient of that middle term. So we're going to make our list of factors. We're asking what multiplies to negative 18 and adds to negative 7. So 1 and 18, 2 and 9. Hey, that's looking hopeful. So I need it to add to a negative, so I need my larger term to be negative, and then I just check 2 times negative 9, negative 18. This coefficient was a 1, so these are what goes straight into our parentheses there. So that's an x squared plus 2 and an x squared minus 9. And now I check, is this fully factored? Squared term plus not squared term, yep. Squared term, negative, squared term, this is a difference of squares. So I can further factor that guy. I know that I've got 1 as a plus, 1 as a minus. My first term for both will be an x. My second term for both will be a 3. And then I bring this guy down. And this is the fully factored version of that. So this was a quadratic, but our first term is an x squared instead of an x to get us that x to the 4th. So just taking a look at the difference one more time. 3 terms, but not a quadratic yet, right? We're going down by 1 degree, x cubed, x squared. So we didn't reveal the quadratic until we factored out a 3x. Yes, a quadratic, x to the 4th, x squared, no x. So this is a quadratic. Okay, so those were 3 examples of more complex factoring where you use more than one method in order to fully factor your polynomial. All right, so keep working on factoring. Take a look at some of the earlier videos and stay tuned for more videos on factoring. And meanwhile, keep on mathing.